Alright, so a quick video to help with the rational functions. You guys are taking the quiz on today by midnight. My guess is that you're working on the homework if you haven't already completed it. If you have and you haven't taken your second attempt, this might help as a guide. I'm just going to address two particular types of questions. One is this. You've seen a graph. You get given this graph. You'll know it doesn't have the grid mapping on the back, so it's not meant to be, it's just meant to give you the core points that you need, and then in words it's giving you those, so you really don't even need the picture. I know many of you get focused on that. So here we don't need the picture. It has a vertical asymptote at x equals 2 and x equals -5. It has a horizontal asymptote at y equals 2. The graph has x-intercepts at 4 and -4, and it passes through the point -2, 2. Now, I can use a lot of this. This usually has a set of 5 or 6 possible scenarios on the bottom. Here's what I know. I know right away that this has to have, just by looking at what they've given me, I know that this has, for my denominator, right? I'm just going to focus on that for a moment. It has x minus 2, x plus 5. And I get that from this piece. This is set equal to 0. This is set. So to solve it, I would minus 2 over minus 2, which is going to be the x minus 2, which is what I have. Same thing for the other one. So that's my, oops, let's not do that yet. That's my denominator. So I already know that. Here's some other stuff I know. I know just from the fact that the horizontal asymptote is 2, I know that the degree on the bottom, so this degree, and this degree must be the same. These two must be equal. I know this because when we talked about polynomials, and when we've used that, we know what the degree is. And then when we were early on, before spring break, we talked about the horizontal asymptotes. And if this degree, the numerator, is smaller than the denominator, then the horizontal asymptote is at 0. If the degree of the numerator is greater than the degree of the denominator, I don't have a horizontal asymptote. I have a slant asymptote. If they're equal, they are the ratio of whatever's out front. So they are the ratio of this. In this case, this piece, they've been lettering A. So I'm going to keep lettering it A. That's what I know. That's okay. That's great information. I'm going to use that in a minute. Now, I also know that this has horizontal, an x-intercept. It has x-intercepts. Well, the x-intercepts has to be when I set this whole thing equal to 0, which means they have to be in here. So that would be x minus 4 and x plus 4. And I get that right here. Again, those are my x-intercepts. So therefore, when I set this equation equal to 0 and I try to solve it, the whole denominator disappears, right? Because I'm going to multiply both the left side and the right side by the denominator, which 0 times anything is 0. So those go away. So I'm really focused on the top piece. And when I divide 0 by a, I still end up with 0. So that means to find the x-intercepts, I have to have y equals 0. So that means that the y here has to equal 0, so I can just do that. Again, I don't need to actually calculate it. I'm using the critical thinking skills and the pattern recognition of what we've already been doing. Now, the only thing I don't know here is a. Now, here's the great thing. here's what I do know. I do know that a over 1 must equal 2, right? And I have that. I've already written that out. Maybe I didn't put the 1. Let me put the 1 so we can make sense of this. A over 1 must equal my horizontal asymptote. So, since a over 1 must equal 2, that means that a is equal to 2. Right? I multiply both sides by 1. I just have a, or just a over 1 is a. So that means that's 2. So now I have this equation. And maybe not even do it in the different color. Let me just do it in black. I have this equation. Well, no, that's fine. X minus 4, X plus 4, and X minus 2, X plus 5. Done. That's it. Now, sometimes its horizontal asymptote is 0. And when it is 0, I know that the degree on top is less. So I know that the degree on top is less. So my degree of my numerator is less than the degree of my denominator. And that gives me choices, right? So then I would have to have used this point to figure out what a is. I would still look at, do I have x-intercepts? And again, if I don't have x-intercepts, then that means I only have an a up top, and then I'm for sure going to use this point here to figure out what that a is. I know that x is -2 here, y is, right? This is my x, this is my y. So for every x, I can replace it with -2. For the y, or the output, I can replace it with 2. This will hold true for that. So that's not really an issue. I don't need to use it. This is just a quick way to handle these problems. If I only have one vertical asymptote, then that tells me it's one of the smaller ones, one of the top ones, and I'm going to use that. And then I'm still going to look at, do I have x-intercepts? So that's the process for those. Now, the other thing that I know may be bothering people is this idea of graphing a rational function. In this case, you have to put your vertical asymptotes and then horizontal asymptotes and kind of go from there. You do have to plot points in each section. So I'm going to put my asymptotes. Again, I'm just putting them so we can see them. They're not part of the graph. They don't actually affect the outcome, other than those are values I can't get. To find my vertical asymptotes, I focus just on my denominator and say x cubed minus 6x squared is equal to 0. The best way to handle this one is going to be to factor it. That's usually the case. I will factor out an x squared. So that leaves me with x minus 6 equal to 0. So that means x squared equals 0. And x minus 6 equals 0. Again, I want to solve this because this is just going to be x equals 0. And this is really something x can't be, right? It can't be 0. But that's the line. That is my vertical asymptote. That's the line I can't be. And then here I add 6 and add 6. X equals 6. All right, again, those are my asymptotes, so let me draw them in. So this is my horizontal asymptote, or my vertical asymptote, and my other vertical asymptote. And these are lines I cannot be in my graph, right? And they're just rough on there. You have a machine that dashes them and puts them in there. But again, they're not part of the graph. That's only for our visual need and desire. It's not reality, which gets weird, and I know that. Then we need to find, so I know that my graph is going to look something like that. What else do I know? I know I can't cross those. I know that this degree, let's do that in a different color. This degree here, 2 is less than 3. I do know that. So 2 is less than 3, so my horizontal asymptote must be equal to 0. All right, so I have that line. Great. So I've now put all my asymptotes, and then it wants you to graph, plot some points. The points they want you to plot are some points over in the left side, between each section, right? So if I think of this, that's between here, between here, between here. And I think the way they word it is one plot on each side of the of each vertical asymptote. So I have a lot of choices. I'm going to go ahead and keep this small and fairly easy to work with. I can work with the just as is, or I can write them out in factored form. And I want to factor the top just because I don't know if it makes a difference, but I'd like to factor it so I'm comfortable with where I'm at. Let's do that in this color. So now I'm going to factor that. X squared is going to be, so x times x. 16 is 2 times 8. It's 4 times 4. It's but it's positive, so whatever sign, it's going to be the same. Also, because that one's negative, it must be negative. So let's see. If I do 2 times 8, that's going to give me a negative 10. That won't work. But if I do 4 and 4, that totally works. So great, that's what I'm going to use. So then this equation is x minus 4 squared over my x squared x minus 6. Great. Now this will help me with plugging them in, just because then my numbers aren't big. I don't have to deal with that silly 16, because I like small numbers. I'm not good with big numbers. All right, so let's see what we got. We have a value over here. I'm going to choose negative 1. Why? Just because it's the closest. Negative 1 in the top is going to become negative 1 minus 4 is negative 5, and we're squaring it, so that's going to be 25. Negative 1 squared is negative 1 is 1, and then negative 1 and 7, so 25 over negative 7. So that's about 3 and something. It's like 3 and 4/7 or something. So I'm just going to go over here. And again, I'm just going to plug in, right? I'm going to plug into the box the point negative 1. So let's see. What would I plug in? I would plug in negative 1 and negative 25 over 7. Right, I would plug that point in, and it's going to put a dot. Negative 1, 1, 2, 3, somewhere about here, give or take, right? It's not exact, somewhere in that ballpark. All right, so then I want to choose something. I can't choose 0 because that's one of my asymptotes. So I'm going to choose 1 just because it's fairly easy to work with. 1 up top is going to give me 1 minus 4 is negative 3, so that's going to give me a 9. So I'd end up with 9. And then 1 is still going to be 1. 1 minus 6 is going to be negative 5. So I have this next point, which is 1, comma, negative 9/5. Okay, again, I plug that one in. And this one would be 1 and then go down about 2, a little bit more than 2, so about here. Awesome. Now, I could really just go over and I'm going to choose one real close to the other asymptote just because I want to see what I'm expecting the graph to look like. So I'm going to choose 5. 5 is a good number. So I plug 5 in. That's, maybe write that one out. 5 minus 4 squared. 5 squared. 5 minus 6. Okay. So 5 minus 4 is 1. Squared is just 1, so that just is 1. 5 squared is 25. And 5 minus 1 is minus 1. Or 5 minus 6 is minus 1. So that's negative. So this is negative 25. Okay, so the point up here again. So I'm putting the point 5. And it's going to give me negative 1 over 25. Great. So that's actually very close to 0, but not quite. So at 5, I'm almost to 0. Well, now that begs a question. Do I actually hit 0? I should check that. I should. Oh, wait. I already know I do. Okay, so I have that point. I'm gonna plug in my my x-intercept because I have one. That would happen when this equals 0. The whole bottom goes away here, so I'm really looking at when does x minus 4 equal 0. Well, that happens at 4. So at the point, I would have this point 4, 0. 4 is going to give me 0. So that means at this point, I hit. But I know I'm coming back down too, so that's something. I do need to check something over here. I didn't need to plug in 5. If I really looked at it, I probably could have done this piece first, and then I wouldn't have had to plug in 5 because I'd know where I'm at. But this tells me that my graph is going to go like this, up, touch, and come back down, but it's not actually going to go through. And then I need to plug something on the other side, so we'll just plug in 7. 7's a very wonderful number here, so 7 minus 4 squared over 7 squared, 7 minus 6. All right, so 7 minus 4 is 3. 3 squared is 9. And then I have 49 times 7 minus 1 is 1, so 49. Awesome. So 9 over 49. So that means at 7, that is still less than 1, so I'm about here. And that's all I need to plug in. That point would be, let's put it up here. That would be the point 7, 9 over 49. So these are what I plug in to the machine. And then I hit the graph button, and it gives me a graph that does something like this and something like this, getting really close. That is not a square, it's more rounded, but kind of hard to do. Anyway, so that's what we're looking at, something like that. Goes down. And it will graph it. So we need to check our intercepts, our vertical asymptotes. Then we need to see where is our horizontal asymptote, or if it's a slant asymptote. And again, we look at the degrees for that. The degrees tell us that. And then we say, okay, we probably should have then said, all right, where is it going to equal 0? And I should have done this piece first, because then I wouldn't have needed this, right? I wouldn't need that if I had done this, because I could use this one, and then this, and this, and this, and it would have only been 4 points. A little bit faster if I'd have thought about it, but I didn't, so I'd have 5 points. It's okay. The way it words is, at least you do need to be careful with your arithmetic, right? Make sure that you're not missing a sign. Again, the most common error is sign errors. I hope you can avoid them, but I know you can't. So you got to be cautious of them, and be aware, if you are prone to make them, to double check those works. Okay? All right. Good luck.